It all started with a discovery that wasn't supposed to happen. In December 1938, in a laboratory in Berlin, a German chemist named Otto Hahn was doing an experiment. He was bombarding uranium, the heaviest known element, with tiny particles called neutrons. He expected to create slightly heavier elements, but the results were strange. Instead of making something heavier, he found a much lighter element: barium. This made no sense. It was like throwing a baseball at a window and creating a pebble. Confused, Hahn wrote to his former colleague Lise Meitner, a brilliant physicist who had been forced to flee Nazi Germany because she was Jewish. She was now in Sweden, trying to make sense of a world that had turned against her. Working with her nephew, Otto Frisch, Lise Meitner thought hard about Hahn's bizarre results. She imagined the uranium atom not as a hard ball, but as a wobbly water droplet. What if the neutron didn't just bounce off but was absorbed, making the droplet wobble so violently that it split in two? This was a revolutionary idea. They calculated the energy that would be released in such a split, and the number was staggering. It was an amount of energy far greater than anything seen from a chemical reaction. They called this process nuclear fission. The atom wasn't unbreakable after all. It could be split, and when it split, it unleashed a power hidden inside the very core of matter. The news of nuclear fission spread like wildfire through the world of physics. It was a thrilling and terrifying discovery. Scientists immediately understood the implications. If splitting one uranium atom released a huge amount of energy and also shot out more neutrons, those new neutrons could then go on to split other uranium atoms. This would create a chain reaction, a cascade of splitting atoms that could release an unimaginable amount of power all at once. It was a scientific breakthrough of the highest order, but the timing was terrible. The world was on the brink of war, and this new knowledge could be used to build a weapon of unprecedented destructive force. This realization sent a chill down the spines of many scientists who had fled Europe to escape Adolf Hitler's regime. What if Nazi Germany, which had brilliant scientists of its own, figured out how to harness this power first? Albert Einstein, the most famous scientist in the world, was so concerned that he signed a letter to US President Franklin D. Roosevelt in 1939. The letter warned that Germany might be developing extremely powerful bombs of a new type. It urged the United States to start its own research program immediately. The message was clear: a secret race had begun, and the fate of the world could depend on who won it. President Roosevelt took the warnings seriously. The United States government secretly launched one of the most ambitious and clandestine projects in history, the Manhattan Project. Its goal was simple and terrifying: build an atomic bomb before the Germans did. It was a massive undertaking, costing billions of dollars and involving hundreds of thousands of people, most of whom had no idea what they were actually working on. Secret cities were built from scratch in places like Oak Ridge, Tennessee, and Hanford, Washington, dedicated to producing the rare materials needed for the bomb, like enriched uranium and plutonium. The entire project was shrouded in a level of secrecy so intense that even the vice president didn't know about it. To lead the scientific effort, the US Army chose a brilliant but complex physicist named J. Robert Oppenheimer. He was put in charge of a secret laboratory built on a remote mesa in Los Alamos, New Mexico. Oppenheimer gathered a dream team of the world's brightest scientific minds: Nobel laureates, promising young physicists, and expert engineers. They were brought to this isolated, high-desert location, a place so secret it didn't officially exist. There they lived and worked under constant surveillance, racing against a ghost enemy to solve the complex puzzles of atomic weapon design. They were driven by the fear of what would happen if Hitler got the bomb first. The scientists at Los Alamos worked tirelessly, debating theories and running countless calculations. They had to figure out exactly how to bring the nuclear material together fast enough to start the chain reaction. They explored two different bomb designs. One used uranium and was shaped like a gun, firing one piece of uranium into another to start the explosion. The other, more complicated design used a newly created element called plutonium. This design required a sphere of plutonium to be perfectly crushed or imploded by a surrounding layer of conventional explosives. The science was brand new, and every step was a journey into the unknown. By the summer of 1945, Germany had surrendered, and the war in Europe was over. The original motivation for the bomb, the fear of a Nazi atomic weapon, was gone. However, the war in the Pacific against Japan was still raging, costing thousands of lives each week. The Manhattan Project continued at full speed. After years of secret work, the scientists had produced enough plutonium for a test of the implosion device. They needed to know if their theoretical creation would actually work. A test site was chosen in the New Mexico desert, a place they called Jornada del Muerto, or Journey of the Dead. They codenamed the test Trinity. The world was about to enter the atomic age. In the pre-dawn darkness of July 16, 1945, the scientists and military officials gathered at the Trinity test site, many wearing welder's goggles to protect their eyes. The world's first atomic device, nicknamed the Gadget, sat atop a 100-foot steel tower, waiting. At 5:29 a.m., it was detonated. A flash of light brighter than a dozen suns illuminated the desert, so bright that it was seen hundreds of miles away. It was followed by a deep, terrifying roar that echoed off the mountains. A giant mushroom cloud of superheated dust and debris rose more than 7 miles into the sky. The steel tower was vaporized. The desert sand below it was melted into a green, radioactive glass now called trinitite. The power unleashed was greater than anyone had dared to imagine. Oppenheimer, watching the explosion, later recalled a line from the Hindu scripture, the Bhagavad Gita, "Now I am become death, the destroyer of worlds." The test was a horrifying success. The secret weapon worked. President Harry S. Truman, who had taken office after Roosevelt's death, was now faced with a monumental decision. He was informed of the successful test while at a conference with other world leaders. He now possessed a weapon that could potentially end the brutal war with Japan, but at a cost that was difficult to comprehend. The atomic bomb was no longer a theory, it was a reality. On August 6, 1945, the American B-29 bomber Enola Gay flew over Japan. It dropped a uranium-based bomb, nicknamed Little Boy, on the city of Hiroshima. The bomb exploded with the force of 15,000 tons of TNT, instantly killing an estimated 70,000 people. A blinding flash of heat incinerated everything at the center of the blast, leaving only shadows of people burned onto walls. A powerful shockwave leveled buildings for miles. In the days and years that followed, tens of thousands more would die from severe burns and radiation sickness. The city was almost completely destroyed, a vision of hell on Earth. Despite the devastation at Hiroshima, Japan did not immediately surrender. 3 days later, on August 9, 1945, a second atomic bomb was used. A B-29 bomber named Boxcar dropped a plutonium-based implosion bomb, Fat Man, on the city of Nagasaki. This bomb was even more powerful, with a force of 21,000 tons of TNT. It killed an estimated 40,000 people instantly. The landscape was transformed into an endless ruin of rubble and fire. 6 days after the bombing of Nagasaki, Emperor Hirohito announced Japan's unconditional surrender, officially ending World War II. The atomic bombs had achieved their military objective, but they had also introduced a terrifying new reality to the world. The bombs dropped on Japan were fission bombs, which get their power from splitting heavy atoms like uranium or plutonium. However, scientists soon developed an even more powerful type of nuclear weapon, the fusion, or thermonuclear bomb. Often called a hydrogen bomb, it works by forcing together or fusing light atoms like hydrogen isotopes. This fusion process, which is the same reaction that powers the sun, requires immense heat to get started, so a fission bomb is used as the trigger. As a result, fusion bombs can be hundreds or even thousands of times more powerful than the bombs used on Hiroshima and Nagasaki, capable of wiping out entire cities. The end of World War II did not end the threat of nuclear weapons. Instead, it kicked off a tense and dangerous era known as the Cold War between the United States and the Soviet Union. For decades, these two superpowers raced to build more and bigger bombs, creating vast arsenals capable of destroying the world many times over. Today, the world is still a nuclear-armed one. There are 9 countries that are known to possess nuclear weapons: the United States, Russia, the United Kingdom, France, China, India, Pakistan, Israel, and North Korea. Together, these nations hold a total of over 12,000 nuclear warheads, each one far more powerful than the bombs of 1945. The invention of the atomic bomb fundamentally changed history. It ended the largest war humanity has ever fought, but also introduced the constant, lingering fear of nuclear annihilation. The stories of Hiroshima and Nagasaki are not just historical events, they are powerful warnings. They show the catastrophic human cost of these weapons and the profound responsibility that comes with possessing such power. Remembering what happened in those cities is crucial for promoting peace and ensuring that such weapons are never used again. It reminds us that our scientific genius must always be guided by our humanity. the world lives in the shadow of the mushroom clouds, a symbol of both human ingenuity and our capacity for destruction. The challenge for every generation since 1945 has been to prevent another nuclear catastrophe. International treaties and diplomatic efforts have aimed to reduce the number of weapons and prevent them from spreading to other countries. The memory of the blinding flash over Hiroshima and the haunting ruins of Nagasaki serves as the most important reason to continue working toward a world free from the threat of nuclear war, a world where such destructive power is never again unleashed.